Hey guys, let's solve the today's problem, all possible full binary trees. Okay, so first of all, what is full binary tree? Okay, if I have a node here, so this node could either have a zero children's or we could have two children. Okay, so the basic thing is we could either have zero children or two children. We can not have one on either side. Okay, means we can put that node on only one side. We can't do this because this is full binary tree. Okay, so suppose n equals to 0, so we can form anything, so return nothing. Okay, so if I have n equals to 1, then I can return a simple node, single one node. Now if I have n equals to 2, then I can't return a single full binary tree, because if I make a node here, then for 2 I have only one child left, which I put here, but this is empty, so this is a binary tree but not a full binary tree. Okay, so we can't do for 2. So suppose we have 3, so I can make a node here with 2 or 3, which is eventually lead us to nothing, but this won't work. Oh, I made 4, but this is the tree, so 3 nodes is good. So let's go for 4. Okay, you will get to know about 4. Now take a node here, so I made 1. Now in this I can make, we have 3 left, so I can put 1 or 2 here, or 2 or 1. Why I can't put 0 or 3 or 3,0 nodes here? Because this would eventually be not a full binary tree. Okay, this won't be a full binary tree. So means either I can put 1 node here and 2 nodes here, or 2 nodes here and 1 node here. Okay, so simple thing is I put 1 and the rest would be here, which won't work. So if I do this won't work, means I can make 4 nodes here. What about 5? 1. If I had 1, then I can have 4 nodes here, means 2 nodes here, 2 nodes here, 1 node, 3 node, 3 node, 1 node. Okay, so I can put 1 node here, then rest 3 are here. If I have 3, I can make the call. So you know that I made a 3 node here. So what I did is just simply put this node here, for n equals to 3, or simply I can have a node, then I can make 2 here and 3, 2 and 4, which want 2, or 2 which want bigger. So what I can think is simply of a recursion. If I have a n node, then I can call for the rest of the n minus 1 with the recursion. Okay, so if I have a node n, then I call and make a set that have all the nodes with left and right. So suppose I have 5 as a n, so I put L equals to from 1 to n minus 1, and for R it would be n minus 1 minus n. Okay, so let's see this. Now first of all, remove the like I'm doing the unwanted things. So I call a function called rec, means recursion. So recursion, I made a temporary vector s to store all the nodes that contain n nodes. If n equals to 0, then I just simply return, because n would be empty. If n equals to 1, then I can make a vector that contains a single node. Let's leave this left. From L, if I have a node like this, then I can either have L nodes on the left or R node on the right. So L would be range from 1 to n, not including n, and for R it is simply math n minus 1 minus n. Okay, so I made a temporary variable that contain all the left nodes, set of nodes which contain L and R which we are. Okay, so temp L, temp R, just simply putting on the new nodes and just appending it to the rest, and now simply putting the rest on the return. Now this would work, but we need a solution that work efficiently. So I put a DP solution memorization here, make a unordered map that contain key and a vector of 3 nodes. If n is already available on the DP, then simply return the DP. Else, just run the function and store that on the DP. Simply, it's submitted. Oh, what the fuck? Oh, I just by mistake put the bracket on it. So, what is n? Oh, sorry. It was like this. I just moved that bracket back. So yeah. So it returned pretty fast. 0. Oh, fuck. So let's. Yeah, it's submitted. Great. So have a nice day. So what will the time complexity? Now this would be of time complexity of 2 raised to power n, and space complexity would be same, 2 raised to power n. Okay, because we are recursively calling all the nodes, so it would be 2 here. Yeah, that's it. And if you need a Python, so here's Python. Okay, see ya.